Alrighty. Today we are diving into the first set of notes for Unit 6. So this is taking another look at triangles. We've done all kinds of stuff with these things so far. We started out with triangle basics and we've done a lot of equations with them. And then the last chapter we spent a lot of time talking about proving things with triangles. This is going to be another angle. We're looking specifically at different ways at looking at the sides and angles of a triangle, comparing them, contrasting them, ordering them, that kind of stuff. So in this first set of notes, we're going to introduce the big ideas, and we're going to build everything around a simple set of formulas that you can do a lot of cool stuff with. Now, it's going to start out complicated, but you're going to learn a set of tricks that are pretty easy to use. So you're going to rely on them to answer the questions in this section. So let's go ahead and dive into it. So, in a triangle, the sum of any two sides is greater than the third side. So you have sides A, B, and C. Any two sides, let's say A and B, is going to be greater than the length of the third side, C. A and C is going to be bigger than B, and C and B is going to be bigger than A. These are the formulas we're going to use. So we're going to say that A plus B, the length of A and the length of B, is greater than C. We're going to say that the length of B and the length of C is greater than A. Lastly, we're also going to say that C plus A is greater than B. 1, 2, 3 formulas. We can use all three of these formulas to answer questions about whether something can be a triangle. So, what we're going to do is we're going to apply all three of these formulas to determine if A is going to be a triangle. So, we're going to go ahead and start by labeling our three given sides. We're going to call this A, this B, and this C. So, we're going to start by asking if 18 plus 19 is greater than 40. No. We're going to ask if 19 plus 40 is bigger than 18. Yes. We're also going to ask if 40 plus 18 is bigger than 19, sorry. Yes. Now, because it didn't satisfy one of these rules, 18 plus 19 is not bigger than 40, then no, it is not a triangle. Okay, so this is the process. We're going to try all three methods, and we're going to do the same thing with B. I'm going to label A, B, and C. And then we're going to go ahead and try our three rules. 16 plus 39, if that's bigger than 28. We're going to test and see if 39 plus 28 is bigger than 16. It is. Both of these are true. Then we're going to ask if 16 plus 28 is greater than 39, which is also true. Now, I want to point out real quick that two of these checks are kind of pointless. So in number 1 and number 2, we're asking if 39 plus something else is bigger than 28. Well, that's obviously true. 16 plus 39 is going to be bigger than 28 because 39 is bigger than 28. We don't really care about this case. Same thing here. 39 is bigger than 16, so we don't even need to add anything. We're wasting our time. The only case we care about is if the short sides are longer than the longest side. If the shortest two sides, if 16 plus 28 is bigger than 39, it is a triangle. So this is a triangle, yes. Same thing here. If the shortest two sides, 18 and 19, are not bigger than 40, which they're not, then it's not a triangle. So instead of doing all three methods for C, we're just going to do the shortest two sides. We're going to check if 33 plus 37 if that's greater than 66. It is, so it is a triangle. Again, we're only going to check the shortest two sides in D. Is 5 plus 5 greater than 10? No, it is not, because we're looking for greater than. 5 plus 5 is 10, and 10 is not greater than 10. So no, is not. You only need to use to check if the shortest two sides are greater than the longest side. Okay, once we've established this, we can move down to E. Instead of checking three sides of a triangle, we're asked what the third side could be. A triangle has sides that measure 11 and 16. I'm going to call these A and B. What are the possible lengths of the third side? Okay, well, let's start out by just checking some. Does 5 work? Well, 5 plus 11, these would be the shortest two sides, is not greater than 16. So 5 does not work. What about 6? Well, 6 and 11 would be the shortest two sides, and 6 plus 11 is greater than 16, so it does work. So we know 10 will also work because 10 plus 11 is 21. That's bigger than 16, so it'll work. Okay, so 6 is going to be our bottom end. Let's try our top end. What does 30 work? Well, in this case, if 30 is our third side, we're going to test 11 and 16. 11 plus 16 is not greater than 30, so this won't work as a third side. What about 25? Well, 11 plus 16 is greater than 25, so it'll work. Let's check 26. 11 plus 16 is greater than 26, so it works. 27. 11 plus 16 is 27, so it will not work. 26 is our upper bound. Okay, so we found two boundaries of what does and doesn't work. There's a formal way to do this. We already labeled A and B. Our C is unknown. So whatever C is has to satisfy these three inequalities. Okay, so let's go ahead and write them out. We have A plus B. My A is 11, my B is 16. 11 plus 16 is greater than C. I have B plus C, so 16 plus C is greater than 11. And I have 11 plus C is greater than 16. Whatever value of C we pick has to satisfy all three of these formulas. Okay, now I can do a little bit of rearranging. I know that these combine to 27. I can subtract 16 from both sides to show that C has to be greater than negative 5. And I can subtract 11 from both sides to show that C has to be greater than 5. Now, what this is saying is that C has to be less than 27 and greater than 5. Notice that that's exactly what we found. This case of negative 5 here doesn't really matter, and the reason why is because our answer is going to be positive. We're not going to have a negative answer ever. There's no such thing as a negative length. So we're going to rewrite what we have here. 27 is greater than C, and C is greater than 5 as this. And what this means is C is between 27 and 5. C is a value between 27 and 5. Your answer is always going to look like this. When you're answering questions about a third side, I always want you to do this range of values. Some number greater than C greater than some number. Now, I know that was a lot of work. Fortunately, there's a trick to do this a lot easier. Ultimately, what we ended up doing was we added these two sides and subtracted these two sides. So to get my upper bound, I'm going to do 30 plus 50, which is 80. To get my lower bound, I'm going to do 50 minus 30, which is 20. That means C has to be between 80 and 20. Okay, that trick is going to make it really easy. Up here, all you do is you check the two shortest sides, see if they're longer than the longest side. Down here, you add up the two sides, you subtract the two sides to get the range of the third value. Okay, we're going to go ahead and flip to the back. And there's two practice problems for you to try. Pause and do that, and then we're going to move on down. Okay, then we're going to move to the middle of the page here. And we're going to, before moving on to the next thing, we're going to talk briefly about what are called naming protocols. So we have to make sure we know how to name our sides and angles. Angles are going to be named with capital letters. But we're going to do something different for the sides. I'm going to call this lowercase b, this is lowercase a, and lowercase c. Notice that the lowercase letters identifying each side is going to be opposite of the same angle. So side A is across from angle A. Side B is across from angle B. Side C across from angle C. We use lowercase letters to know they're different. So sides are named with lowercase letters. And a side is named by its opposite angle. So we have something here with ordering angles. The smallest angle is always opposite the shortest side. The largest angle is always opposite the longest side. So we can actually order the angles from least to greatest by looking at their opposite sides. Angle A is across from 7 feet, so angle A is the smallest angle. The middle side is 10. That's going to be angle C is our middle angle, and our widest angle is B because it's across from the longest side. Same thing here. We're going from least to greatest. Our shortest side is 15. It's across from A. A is our smallest angle. B is our middle side. B is our middle angle. C is our longest side. C is our longest angle, widest angle. Go ahead and try the same thing with J. Order the angles from greatest to least. Okay, the last idea with these notes is the converse of that, ordering sides. So the shortest side is always across from the smallest angle. The longest side is always opposite the largest angle. So, given these two angles here, I know that this last angle is going to be 35. The smallest side is across from the shortest side is across from the smallest angle. My smallest angle is F. My smallest side is F. My middle angle is E. My middle side is E. My largest angle is D. My largest side is D. Same thing down here. My smallest angle is B, so my smallest side is B. My middle angle is A, so my middle side is A. My largest side is A, my largest angle is A, so my largest side is, I'm totally getting this wrong. My largest angle is C, so my longest side is C. B, A, C. Okay, so I want you to try L, and that'll wrap up these notes for today. Once you're confident with it, you can try the homework, and as always, let me know if you have any questions. Have a great day.